Units 4.4 and 4.5, proving triangles are congruent. We have 6 ways to prove triangles are congruent. In 4.3, we did it using the definition of congruent triangles, where we had to show the following. Sets of corresponding sides congruent, and sets of corresponding angles congruent. To be clear, we had to show all 3 sets of each one of them are congruent. So looking at the picture provided here, we had to show that angle A was congruent to angle R, angle B was congruent to angle S, angle C was congruent to angle T, and for the sides, we had to show that AB was congruent to RS, AC was congruent to RT, and finally that BC is congruent to ST to get that triangle ABC is congruent to triangle RST. What we're going to look at in this lesson are some shortcuts. The first one is side, side, side. Here, all we have to show is that the 3 sets of corresponding sides are congruent. If we can show that the 3 sets of corresponding sides are congruent, we can say that the 2 triangles are congruent. The next shortcut is side angle side. Here the angle is between the 2 sets of congruent sides. So in the picture here we have this angle and we have this angle. The 2 sets of congruent sides are here. The angle is in between them. So all we have to show is that 2 sides and the included angle. Included means it's in between the 2 sides. The next shortcut is angle side angle. Notice that the side is between the 2 angles in the pictures. So here we show the 2 sides and the included, we show the 2 angles and the included side. The next one is angle side angle. So this is 2 angles and the not included side. So we have this angle congruent to this angle congruent to this one, and the sides. The last one is only for right triangles, and it's called hypotenuse leg. If you know that it is a right triangle, all you have to show is that the hypotenuses are congruent and one of the legs are congruent. So hypotenuse leg. And if you look at this, this is actually angle, angle, side, side. It's the only case of angle, side, side that works. There are certain ones that will not work. One of them is side, side angle. As we discussed up there, the only time that works is with right triangles, and it is called hypotenuse leg. That's because of the fact that if you have this situation, 2 things can happen depending on the length of one of the sides. The other one that does not work is AAA. So with AAA, let's look at an example. If I draw this triangle here, draw a line right through there so it's parallel. Let's call this A, B, C, D, and E. We know that since BC is parallel to DE, that this angle right here is congruent to this angle by corresponding angles, and also by corresponding angles, we know that these two angles are congruent. So let's take apart the triangle, the two triangles. We have triangle A, B, C, and then we have the large triangle A, D, E. We know that angle D here is congruent to angle B. We know that angle C is congruent to angle E. And this angle right here is congruent to each other because they're the same angle. But they're two different triangles. They are not congruent. So that's the reason that AAA does not work. So let's look at some examples here. You're going to determine if two triangles are congruent. If they are, state why. In this picture, we know that there's another set of congruent angles because of vertical angles. So these two angles right here are congruent because vertical angles are congruent. So letting our fingers do the walking, we have one set of angles, then we have the side in between, and we have another set of angles. So this is true by angle, side, angle. The next picture, we have two sets of congruent sides, but both of these triangles share a side. So that side is also congruent to itself. So these are true by side, side, side because they share a common side. Again, on the next one, this one shares a common side, but if we look at it, we have this side congruent to this side, the shared side congruent, and then the angles. So we have side, side, angle. So side, side, angle does not work, so this one is no. For the next one, we have a shared side again. Looking at the picture, we have an angle, side, angle. So this one is true by angle, side, angle. Again, we share vertical angles here are congruent. So we have side, angle, side. So this is true by side, angle, side. Here we have a shared side again that's congruent. We have right triangles. So we have the hypotenuses are congruent and one of the legs. So this is true by HL. Here we have to determine whether triangle ABC is congruent to triangle KLM. We can't do it with angles, so the only choice we have is to show that the three sets of sides are congruent. So I look at AB and KL first, using the distance formula. So AB is -3 minus a -1 squared plus 3 minus 3 squared. So that gives us the square root of 3 plus 1 is -2 squared, which is 4. 3 minus 3 is 0, so 4 plus 0, which is the square root of 4, which is 2. Next we go to KL, it's right here, which corresponds to AB. So KL, looking at that one, would be 1 minus 3 squared plus 4 minus 4 squared, which is -2 squared, which is 4. 4 minus 4 is 0, and 0 squared is 0, which gives us 2. So we know that AB is congruent to KL. The next set that we have to look at would be BC and LM. So we're going to look at BC and LM. the length of BC would be -1 minus a -3 squared plus 3 minus 1 squared. -1 plus 3 would be -2 squared, which would give us 4. 3 minus 1 is 2 again, which would give us 4, so we have the square root of 8. The side that corresponds is LM. So 3 minus 1 squared plus 4 minus 6 squared. 2 squared is 4. -2 squared is 4. So we're at 8. So we've proven that BC is congruent to LM. We have to do it for the final set of sides, which is AC and KM. So AC and KM. AC would be -3 minus a -3. Plus 3 minus 1. Both of those squared. So -3 plus 3 would be 0. 3 minus 1 is 2. 2 squared is 4. So we have 2 again. Then we need KM. One minus 1 squared plus 4 minus 6 squared, which will give us 0 squared, which is 0, -2 squared, which is 4, which gives us 2. So we have that AC is congruent to KM. Therefore, we have that triangle ABC is congruent to triangle KLM. And that's by side, side, side. And that concludes the lesson 4-4 and 4-5.